Let's start from your questions. If you have questions about problems from our last topic, you can ask, and I am ready. I will try to answer all your questions.
Okay, can you do number 10? I had some problems there.
Okay, just a minute, Idris. I will open it. Number 10. Okay, good question, Idris. Let's do it together. And so we need to find local extrema for this function. First of all, what is local extrema? Extrema is just common name of minima and maxima. So extremum, it's common name of minimum and maximum. And in case of function of two variables, I hope in case of function of two variables, I hope you remember our algorithm, step by step, what we should do to find local extremum. Let me to rewrite this function to be clear for everyone. Fxy, it equals x square minus y square plus 2x plus 6 times y minus 4. So step 1 here is to find first order partial derivatives, respect x and respect y, and then find critical points. Critical point, it means we should equate these partial derivatives to 0. Okay, let's start. First, let's find partial derivative respect x. And let's recall again and again that when we are finding partial derivative respect x, y, we should treat y as constant. So in this case, variable we have x, and variable of x square is 2 times x. What is derivative of y square? It's easy because
0.
It's constant, it's 0. I can write 0 or I can miss it. Okay, so I will write it's this 0. Next, what is derivative of 2x? Derivative of 2x, it's 2. Okay, and as for last terms, 6 times x minus 4, it's constant, and that's why it's 0. So we have here plus 0. It equals 2x plus 2. It's partial derivative for respect x. Any questions so far? Okay. Yeah. Now let's partial derivative for y. Partial derivative of for y it's going to be please help me to find partial derivative.
Here will be minus 2y plus 6.
So it's minus 2y, I agree, minus 2y plus
6.
Absolutely. Absolutely. Now, we should now equate both to 0, 2x plus 2 equals 0, and minus 2y plus 6 equals 0. And from the first equation, we have x equals -1. And from the second equation, we have y equals 3. That means that this point, -1, 3, it's critical point. But we don't know yet. We don't know. It may be local maximum, it may be local minimum, or it may be neither. Not local maximum, not local minimum. And to determine what type of point is it, we should calculate d. And what is this d? This d, it's we denoted it A and C, and how? Do you remember? Okay, I will write.
The formula here is A multiplied by C minus B.
I will write down without A and C. We can use these denotions A and C, and we can write down without these denotions. It does not matter. What does matter? So fxx and by fxx, it's second order derivative respect x, and we in the previous class we denoted it by, okay, I will write down the same denotions. So this d, it's A, and we know what is A. A is fxx, second order derivative respect x, times C, and C is second order derivative respect y, and minus b square, and b, it's second order derivative, but it's mixed partial derivative. Mixed in meaning that first we should find partial derivative respect x, and then after that we should find partial derivative respect y. So we can denote it by fxy. So our next step now is to find this partial derivatives and then replace x and y by our critical points. And our critical points here are -1, 3. So this A, okay, I will write down now more clear. This A, it's fxx -1, 3. B, it's fxy -1, 3, and C, it's f y -1, 3. Okay, so next step is to find fxx. F sub xx, it means to find second order partial derivative. And second order partial derivative, it means from the first order partial derivative, take first partial derivative respect x. So it's going to be, we have here this first order partial derivative, and now I will find this partial derivative, and to indicate that I'm looking for partial derivative respect x, I will write down here x. So it's clear, I think. What is this derivative? It's 2. It's 2. It's constant. And because it's constant, it will be the same if I will replace x and y. So now I have just found a, it's f(x) minus 1, 3, and it equals 2. So when I got partial derivatives, there are no x. To be more clear, I can give example of function of single variable. For example, if fx is x squared and we need to find f2, we know what to do. We should replace x by 2, and it's 2 squared, it's 4. And also, if we have constant function, fx equals 5. Also here we can write down that f2 is 5. It's constant. For f of 2, it's 5. For f of 100, it's 5 again. So it's just for analogy to be more clear. Okay. So in the same way, I can write down that f of y xy, it's
there will be -2.
Yes, absolutely.
-2y.
Yes, absolutely. It's minus 2y plus 6, minus 2y plus 6 respect y, and it's going to be, Idris is absolutely right, it's -2. And finally, I need to find fx y. So this is b. B, we know it's -2. In the same reason as in the previous row, fxy, it's 2x plus 2 derivative respect, no, sorry, I missed here. xy. So it's we can take first order derivative respect x, and then take for that derivative respect y. So we have 2x plus 2 and derivative of this 2x plus 2 respect y. What is it?
It is 0.
It's 0. It's 0. Now, what now about our number d? Our number d, it's a times b. So here we have c equals 0. So what is d? D is a times c minus. Oh, I confused here.
I'm sorry, but C is F by Y.
Yes. I confused here. So it's C. It's C. Very good. It's C and it's B. It's B. I think now it's correct. Here is correct. B is -2 and C is -2. Okay, here is correct. I made just one mistake there. Do you agree? Do you agree? Is everything correct?
Yes.
Look very critically.
I have written the whole homework the other way, like C is FYY.
What is C?
I have written C as B in my homework. And you have here this
It's
kind.
like doesn't matter which letter you wrote.
Okay. It
No,
doesn't
it matters.
It's
More
it doesn't matter.
you-
But however, we should use the same denotions to not confuse. So you are right, Georgi. So here, X, Y. How we denote it? Fxy. Fxy. How we denote it? It's B. Yes.
Yeah, it's B.
Okay, it's B. And it's C. It's C. Okay, so now here we have FYY. It's C. Here should be C. And Fxy is 0, and it's according our denotions.
B, yeah.
According our denotions, it's B. Okay, now what is our number D? D, it's A times C minus B squared. So it's 2 times -2, and it's negative. So it's negative. It just means that this function does not have extremum. So function extremum have only in case when this number D is positive. This number is negative. It means that this function have no. This function has no maximum, not maximum, not minimum.
But why? Am I I just wrote there like because D D will be -4, yeah, it's negative. And
Yes, it's
A
negative.
will be +2. So it means that here we will have local max minimum, yeah? Not?
Look, Idris, look, when we calculated this D, there we have 3 cases. D, when we have D, there we have 3 cases. D is positive. It means that function has local maximum or local minimum. This is first case. Second one, D less than 0. D is negative. It means this function have no maximum, no minimum. And when D equals 0, it means that this test fails. We have no answer. This function have maximum or minimum. If
okay, I got it.
If D is negative, it means that we finished solution. Our answer is there are no maximum and there are no minimum. Or shortly, you can write there are no extremum. When D less than 0. When D is positive, it means it has a local maximum and or local minimum. And you should define then this is a local maximum or local minimum. And its local minimum or local maximum, it depends from the A or F, X, X, A, B. If X, X, A, B or A by our denotions, it's negative. It means we have local maximum. If this fxxab, or I can write down shortly A, if fxxab positive, it means that it's local. If it means it's local minimum. Just a minute, I have no enough place here, and so this is maximum, local maximum, and this is minimum. So if D is positive, then you should decide by sign, by parity or by the sign of A. It's maximum or minimum. And if D is negative, it means it's finished. Solution is finished, and answer is no extremum. No extremum. And this, it means that test fails. So we have here 3 basic case, and in the first case we have 2 cases when A is negative or A is positive. Okay, let's do one more problem about it to be more clear.
Okay, thank you. I got it.
Okay. All. And is there any number what is interesting for you from homework?
Wait.
Sorry, can you do 28?
Yes. 28. Just a minute. 28. Okay. So here we have, it was from your homework, 28.
No, it wasn't. You have wrote like we need to do from 5 to 10, yeah?
28. Okay, but we can show it. It's interesting problem and we can solve. So, so here we need to show that 0, 0 is critical point. And how we show? We need to find derivative respect x and derivative respect x. It's little bit challenging because here we should use chain rule, and chain rule we should use here to find derivative of e to power x y square. And can you say me, what do you think? What is derivative of this? Respect x.
Just e y square in the power.
I can give you analogy. For example, in the case of function of a single variable, what is derivative of e to power 5x? E to power 5x, it's e to power 5x, and this derivative we should multiply by derivative of 5x, and it's 5 times e to power 5x. And we can use this analogy here, and we can write down that derivative of first term e to power x y square, it's y square times e to power x y square plus, now in the second term there y cube, it's constant, and that's why our derivative is 2 times y cube x, and derivative of 2 is 0. Any thoughts? As for derivative of respect, partial derivative respect y, so this is what I wrote down. It's derivative respect y. As for derivative respect, it's derivative respect x. As for derivative respect y, in the first term we can use the same chain rule, and this derivative is going to be x times e to power x y square plus, what will be derivative of second?
Don't we need to write like 2x multiplied by e? No, because y square will be 2. Or maybe I'm wrong.
So here. Oh, yes, very good. Because we have here, oh, very good, Idris. Great job. I use analogy, and analogy, it's not good friend sometimes. Very good. Excellent job. So.
Thank you.
So here, okay, let's do it more carefully. E to power x y square, we should find derivative respect y, and this derivative respect y, it's e to power x to power y square, and then we should multiply by x times y square, derivative respect y, and this derivative respect y, let's first rewrite it, x y square, and this derivative respect y, x here is constant, and I can move out of derivative, and as for derivative of y, it's 2 times y. So here we have 2xy. Is it correct now, Idris? 2xy.
Yes.
Oh, thank you very much. It's great. Xy square. Okay, so let me correct this mistake. So we have 2 times xy times e to power x y square. Okay, and what is next derivative? Derivative of second term, x square times y square, and x is constant. X is constant, so derivative here is going to be, I think, 3 times x square y square. Do you agree?
Yeah. Yes.
So I can erase it. Okay, so I got 2 partial derivatives, and now I need to equate it to 0. And let's equate first. Y square e to power x y square plus 2y cube x equals to 0. And from the second partial derivative, we have 2 times xy e to power xy square plus 3 times x square y square equals 0. So it's more complicated, slight difficult problem, because in our previous examples, we got constant numbers, and it was more easy. But now we should solve simultaneously these equations, and to solve these equations, we can factor out from the first equation. We can factor out y square, and we have e times e to power xy square plus 2xy equals 0. And from the second equation, we can factor out x times y. And we have 2 times e to power xy square plus 2xy equals 0. Now, we can see now that when product of 2 factors is equal to 0, it means that y square equals 0, and here x is equal 0. So we have y, we have that when x equals 0 and y equals 0, and this x equals 0, this point 0, 0, this is critical point. So here in this problem, there are 2 parts, and we did first part. We proved that 0, 0 is critical point. It does not mean that this function have no other critical points, but it was required to show that this point 0, 0 is critical point, and we showed it because when x equals 0 and y equals 0, these both partial derivatives are equal 0. Now, if we will find now our D, now we should find fxx, we should find fyy, and we should find fxy. And to prove that this test fails, it means we should get that D equals 0. So maybe good idea to try it. Who asked this question?
Me. I ask.
Oh, Sadaf.
Yeah.
Please try it at home because it takes now a long time. It takes a long time. And
yeah. Okay. Thank you.
Idea is that you should find all these derivatives, then you should find number D, and if this number D is 0, it means that it's proved that test fails.
Okay. Thank you.
This case, look, this last case, when D equals 0, test fails.
Yes. Coco.
Any other question?
And for the first question, we just try to solve fx, then xy, and also fyxy. We didn't need to solve a local extrema for the first question.
For the first question, do you mean this problem?
No, it was 10.
But which number, Sadaf?
Number 1.
Number 1, okay, let me
I just want to know that we don't need just to solve the local extrema, or we need to do it.
Okay, just a minute, I will see.
Okay.
In the problems, find and explain using theorem why has no local extrema. Why it has no local extrema. Okay, let's try and answer this question. Why it has no local extrema? Let's, it's easy and it will take short time. So, what is fx, xy? Fx, xy, it's 4. What is f? Okay, and this is xy, and this fxy, it's, can you help me? It's 5.
Yeah.
Now, we told that function to have a local extrema, it's necessary. It's not sufficient, but it's necessary to have critical points. And critical points, it means that first partial derivatives should be equal 0. But here, first partial derivatives, we got 4 and 5. It cannot be equal 0. There are no x and there are no y. We got these constants, first partial derivative, and it cannot be 0. So you should write here no critical points, no critical points, no critical points. Hence, no local extrema. hence no
Okay.
local extrema. Because
I got it.
to have critical points, it's necessary, not sufficient, but necessary.
Okay, thank you.
Okay. Any other problem? What about 8? Did you solve number 8?
Yes, I did.
And does it have is there, Idris, is there maximum or minimum?
Yeah, wait. There will be local minimum. Yeah, there will be local minimum.
It's local min. It has local minimum, yes?
Yeah, because there's fxx equal 2 and d equal like more than 0.
Okay, okay, very good, very good. Oh, Idris, you did great job. Okay, and is there any problem when test fails?
Test fails?
Yes.
Fails when it's like 0, yeah? When d is 0.
No, 0, it does not mean that test fails. In the first, it does not mean, in the first number, it does not mean that test fails. We know definitely that it has no local maximum, not local, because there are no critical points. But test fails, it means when we have critical points, we found critical points, and this D, we calculated D and we got 0. If D, we got 0, it means that test fails. And was there any from your homework like this? No?
Yeah. But, you know, now we can write it like to be sure in this topic, like to know more correctly. We can write it.
Which one?
Number 8.
Number 8, okay.
Yeah.
Okay, so in the number 8, so what is first partial derivative, xy? First partial derivative, xy.
There will be 2x minus 4, yeah.
2x minus 4, okay.
4y. 2y plus 6.
2y plus
6.
Okay, and now we can write that critical points are 0, negative, not 0.
2.
Yes.
2 and minus 3.
2 minus 3.
Yeah.
2 minus 3, it's critical points. Okay. Now, what is f, x, 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 y?
Here I got 2.
It's 2, correct. Okay. And we denoted it by a.
Yeah.
Okay. What is f, y, y?
Y is also 2. Yeah.
It's also 2. We denoted it by c.
Yeah.
And finally, f, x, y.
fxy 0.
fxy is 0, and we denoted it by b.
By b.
So now looks our number D. It's going to be positive.
Yeah.
It's going to be positive because
2 multiplied by 2 minus 0
2
square.
times 2 minus 0, and it's positive.
Yeah.
So now we know definitely that it has local maximum or local minimum.
Yeah.
And it has local maximum or local minimum. We should now use A. A is positive. A is positive, and we can write here A equals 2 and it's positive, and hence
Local minimum.
it has a local minimum. Local minimum. Okay, and now
here, yeah,
how can we find this local minimum? How can
we like have to put critical points, yeah.
Absolutely, absolutely true. So we should put these critical points in the original function, and these critical points are 2, -3. So we need now to find f2 -3. And do you have answer for this?
Yeah, here will be 10, but first of all we have to put and 2 square plus.
Yes.
2
so
square.
it's easy to calculate. It's easy to calculate,
Yeah.
and this will be local.
10.
Okay.
Yep.
And let's trust Idris. So it's a local. It's local minimum. It's local minimum. More questions, please?
No, thank you.
I'm sorry, I have a question. We should put 2 and -3 into the original equation, yeah?
Yes, I will show now, Idris. Just a minute. In the original function,
Okay,
I will show just a minute. So it's number 8. Number 8. So f 2 minus 3 in the original function. And in the original function, it means it's 2 square plus minus 3 square minus 4 times 2 plus 6 times minus 3 plus 23. And as told Idris, and we trust Idris, it's 10. And this is local minimum. Why local minimum? Because A is second order partial derivative respect x. It's positive, and that's why it's a local minimum. That's why it's local minimum. So remember very well this chart. Look, this chart. First of all, what is D? You can use or you cannot use these denotions A, C, and B. It does not matter. What does matter is that first term here, it's product of second partial derivative respect x, fxx, and second partial derivative respect y, fyy. And from this product, we subtract square of fxy. You can use these denotions A, B, C, or you cannot. As well as D, you can use or you cannot. You can calculate it without denotion D. In some textbooks, they used these denotions, and in some textbooks without any denotions. Please, if questions or if you interested in some problems, ask me and I am ready to show you how to solve it. So remember this schedule. In fact, our exams, our quizzes are open book quizzes, and in fact, you can rewrite it and then check on your notebook, or as well as you can use our lecture materials during our quiz. Okay, if no questions, I can send you our last quiz. Let me one statement. From the next week, there will be no homework, but these homework points and the maximum point, you know, it's 1.5. We will add 2 presentation points. So in the presentation, maximum points, there is 5 points. And if you will do this presentation, you can get 6.5 points. And 1.5, I will enter it in the homework, last homework, and 5 I will enter it in presentation. So our next presentation, it's together, homework and presentation. So you don't need to send something, homework.
Is the presentation topic free?
Yes, it's free and of course related with mathematics, and it's the same as during first presentation.
We have to send the presentation on email, right?
No, it's not necessary to send presentation on email. It's not necessary.
Okay.
Any questions?
No.
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 Okay, so I can send quiz right now, or you can take break. I think it's maybe it's a good idea to send right now, and
Yes, I think it's a good idea to send right now.
okay, Ketevan, I will send now, and you can rest during your quiz. Okay, just a minute. I sent. Please try to find it in the files. Did you find it?
Yes.
Okay.